Hi guys, this is my instructional video for Thursday. Today you'll be learning about the forms of energy. Now open your notebook and copy the following notes from the slides. You will not need to draw all the images. So start on that. So this is the forms of energy. Okay, please copy your get your notebook so you can copy some notes down. So the forms of energy. Energy is the ability to do work. You need energy to force an object to move. You need energy to make matter change. The blowing wind, the warm sun, and a falling leaf are all examples of energy in use. Energy makes motion and change possible. So, potential energy, like we've talked about in the past few days, is stored energy. It is the energy that isn't being used at that moment, but is waiting to do work. Think about a boulder sitting on top of a hill, sitting there. The boulder isn't doing anything, but because it is sitting on top of the hill, it has the potential to roll down and do work or hit something. Okay. And here's some examples at the very bottom. Then we go into kinetic energy. And again, we talked about in the past few days, kinetic energy is the energy in motion. The energy is performing work. So moving water, wind are good examples of kinetic energy. So as you see here in this picture, the boulder rolling down the hill is using kinetic energy. Changing from potential to kinetic. Okay, so energy can change from one form to another. A good example is a roller coaster. As it travels up, it is using kinetic energy since the energy is in motion. But when the coaster reaches the top, it has potential or stored energy. When it goes down the hill, it is using kinetic energy again, and it's much greater. Okay, so what you're going to do here on this side is you're going to click and drag these names of potential kinetic to the right places. Label the diagram below as examples of potential kinetic energy. Now, slides 6 to 15 are all forms of kinetic energy, so um, you can start jotting some notes down. Whatever is, gets your attention. There is very important points on these notes. Sound, energy produced by sound vibration as they travel. Okay, so how does sound work? What is actually traveling to your ear when you hear an alarm clock ringing? Nothing except energy. No air molecules move very far. They just vibrate, move back and forth. So, sound energy is like our vibrations that travel through the air or another medium that can be heard when they reach a person or animal's ears. Okay. Radiant means light. They're like the movement of light particles. Light is made of electromagnetic radiation and travels in a straight line. And that's how a little bit about how light works. The speed of light, okay, is the speed at which light travels. It is about 300,000 kilometers per second. Nothing travels faster than light. So the white light from the sun is made up of different colors. The white light contains all the colors of the visible spectrum. The colors of the visible spectrum are like the red, the orange, the yellow, the green, the blue, the indigo, the violet. So again, radiant means light. And sending out light, shining or glowing brightly. That's another meaning of radiant. Thermal energy is heat, is the internal energy of an object due to the kinetic energy of its atoms or molecules. So the atoms or molecules of a hotter object have greater kinetic energy than those of colder ones in the form of vibrational, rotational, or the case of gases. Okay, translational motion. Electrical is when motion, light, or heat is produced by an electrical current. So like the TV, the blender, the computer, the electrical cord. Okay, it's the flow or charge of particles called electrons. Electrical energy is the energy that is caused by moving electrical charges. Since the electrical charges are moving, this is the form of kinetic energy. The faster the electrical charge are moving, the more electrical energy they carry. So this is a really good example of electrical energy. Mechanical is the energy of motion that does work. So anything that's mechanical, like scissors, stapler, pencil sharpener. Um, so mechanical energy lets an object apply a force to another object to move it. When a person pedals a bicycle, the energy from their body is used to put the bicycle into motion. So that's mechanical. Okay. Now, from slides 16 to 22 are all forms of potential energy. So now you're going to title your notebook Forms of Potential Energy. Mechanical energy is is the sum of potential energy and kinetic energy. It is energy associated with the motion and position of an object. Chemical. So chemical is energy stored in the particles that make up food, fuel, and other matter. Okay, so chemical energy is energy that's stored in the bonds of chemicals. It is released in a chemical reaction, often producing heat. So, batteries, petroleum, natural gases, and coal are all examples of stored chemical energy. Once chemical energy is released from a substance, that substance is transformed into an entirely new substance. So, like burning paper is chemical, digesting food is chemical, exploding dynamite, they're chemical. Okay, so this is a very good example. This part right here, this information that I just read, very good example of chemical. Chemical energy is the potential of a chemical substance to undergo a transformation through a chemical reaction to transform into other chemical substance. So examples include batteries, food, gasoline, and more. Nuclear is energy stored in atoms. So how does nuclear energy work? Okay, back at nuclear, sorry about that, but back at the nuclear is energy stored in atoms. So, how does nuclear energy work? Nuclear power is used to make electricity. Inside a reactor, atoms from a fuel called uranium are split by neutrons, including fission. So, this energy is released as heat, which is changes the water into this steam that turns turbine generators. Okay. So nuclear energy is energy released during nuclear fission or fusion, especially when it's used to generate electricity. Okay. Gravitational. Gravitational is when motion like water going over a dam is caused by gravity's pull. So gravitational energy, how does it work? Well, energy held by an object because of its height. Gravitational potential energy is created by raising an object higher. The more mass an object has, the more gravitational energy it has. The higher an object is, the more gravitational energy it has. This is very, very important. So please add these in your notes too. Elastic, the last of the notes, elastic. Elastic is stored in a stretch elastic band or spring. You can see here at the bottom. So spring energy is found in materials that can stretch when a force is placed on them and then later return to its original shape. Okay, so like a spring, okay, or the arrow, the bow and arrow, okay, or the rubber band. So many materials and objects can act like a spring and contain spring energy that can look very different than a spring. Some other examples are a trampoline, shock absorbers, a slingshot, a stretched rubber band, a bow pulled back with an arrow, a stretched bungee cord, or a wound up spring toy. Okay, guys, well, that's the notes for today for Thursday. Thank you, guys. Bye.